Okay, welcome back. Good afternoon to all of you. I hope that in yesterday's session, whatever we discussed regarding the relational algebra, all of you understand all the things. Okay. So in yesterday's class, we finished at that point that we complete the select operation and the projection operation. For the select operation, basically we use the sigma operator, that is for the operation purpose, that is select, and R is for the relation and P is stand for the selection predicate. So basically it's looking like that select the instructor name whose department name is physics. So select those tuples or rows from the instructor table whose department name is physics. So for that purpose, here the relation name is instructor, that is R, and the selection predicate is department underscore name equal to physics. Okay. So we covered that thing in yesterday's session, that select operation as well as the project operation. So in select operation, as we know that thing, that we may use different comparison operator and some different connectives, that is and or not, for specific purposes if more than one conditions are there. And that is the project operation. In project operation, we know that whenever we are not going to fetch the whole row or the whole tuple, instead of doing that thing, if I want to check that some of the values, or if I want to check some of the attribute values or some of the column information only, then basically we use the project operation. Okay, means whenever you are directly want to fetch some specific column, then we use projection, and when we want to fetch the whole row, then we use the select operation. That is the difference between the selection and projection. Okay, so that is the basically the project here in instructor table. Total 4 parts there: instructor ID, name, department name and salary. So from that, if you want to project only the ID, name and the salary from the instructor table, then you can use this type of projection operator. Okay, so that is the projection operation example. So in and that is the composition of relational operation. Composition of relational operation, in the sense we are going to basically talking about the relational algebra. Meaning is that, for example, if the query is like that, find the name only, not the whole tuple. Find the name of all the instructor, those who are belongs from the department of physics. So how can you proceed? So first you have to identify that how many of the instructor or how many of the tuples are from the physics department. So for that purpose we use the select, that select from the instructor where the department name equal to physics, and from this rows, from this number of rows, these are the answer, from this number of rows, total 2 rows are there. So from this number of rows you have to find the name of the instructor only, that is the Einstein and the Gold. So using this project operation by the attribute name, you have to show the result. So that is the composition of the relational operation. Meaning is that you may add select and project operation in a single sequence with some specific selection predicate. Okay. So next is that we already discussed that thing, hopefully, that the Cartesian product. Cartesian product is basically, in last session I hope that we covered that thing. Cartesian product meaning is that cross product. Simply it's may consider as the cross product. Cross product meaning is that each of the tuple from the first table, just understand my point, we construct a tuple of the result out of possible pair of tuple. Means one specific tuple, each of the tuple from the instructor table is mapped with each of the tuple from the teacher's table. Meaning is that one-to-one relationship. If in first row total 5 tuple are there, and in next table total 10 tuple are there, then there is near about 5 into 10, total 50 new tuple must be generated. Means each of the tuple from the first table should be mapped with each of the tuple from the next table. So the number of tuples in newly generated table is 5 into 10, that is 50. Okay. So in instructor and teachers table, in our previous example we already seen that in instructor and in teachers table, where in instructor table instructor ID is common, in teachers table teachers instructor ID is also common. So whenever we are going to map that two things, so that time maybe we are facing a problem that in first table instructor ID is there and in next table again the instructor ID is there. So to differentiate the both the column, because if we mapped in as it is format, so in newly generated table the column name, the two column name should be same. So to avoid that thing, here we take and concept that thing that irrespective of the instructor ID, in first table you may use the instructor ID column as instructor.id, and in second table, in teachers table, the instructor ID is replaced by the teachers.id. That is just for the assumption, means that is just for the assumption, no logical changes are there. So it's looking like that. From the instructor ID, each one of the tuple, means the first tuple, that is 10101 Srinivasan, is mapped with each one of the courses with the different, maybe different instructor ID is there, that is a different issue. Means one instructor, means one specific tuple is mapped with each and every tuple from the teachers table. So that is the Cartesian product, that is the simple Cartesian product. Okay, so we covered that thing. Next we focus on the join operation. Now the things has been quite changed. So Cartesian product is just a haphazard result, meaning is that if you have total 10 teacher and total 500 students, if one single teacher is mapped with each of the student, then the total number of tuples is 10 into 500, that is 5000 tuples may be generated. Okay, so to avoid that thing, there is basically some differences between the join operation and the Cartesian product. So in Cartesian product, we know that instructor cross teaches, means every tuple of instructor is associated with every tuple of the teacher. Okay, so if we check in the previous example, here most of the tuples have no role, meaning is that most of the tuples, why the most of the tuples have no roles? For example, here the instructor ID is 101 and in teachers part the instructor ID is 101, means the ID 101 means Srinivasan from the Department of Computer Science, whose salary is 65,000, is taking the course 101, 3 CS 315 and CS 347. That is the relevant information. But whenever from this table you can't judge that thing, because here 101 Srinivasan is mentioned and here in course ID another ID is mentioned, that is 12121. Meaning is that where the instructor ID and teacher's ID matches, you can easily say that thing that the particular instructor teaches this particular courses in the particular semester. I hope that you understand my point. Meaning is that in Cartesian product, whenever you generate different number of tuples, if in the single tuple, if the instructor ID value is same with the teacher's ID value, means this particular instructor is taking care of this particular courses. There is no doubt. But if the particular instructor ID is not matched with the teacher's ID, meaning is that here is there is some lacuna, meaning is that the particular instructor may be taking these courses or may not be taking these courses. So depend on the teacher's ID, you may clearly say that thing, this particular instructor is not taking these courses. So meaning is that from this total 5000, 10 into 500, from this total 5000 record, if you check, only some minimal value is important, rest of the part is totally garbage values. So here we are seeing that thing, most of the resulting rows from the above information about the instructor who did not teach a particular course. So to get only those tuple, actually the instructor teaches the particular courses, here we are create this particular conditions that from the Cartesian product of the instructor and the teachers, means this particular result. From the Cartesian product of the instructor and the teachers, find out, or from the Cartesian product of the instructor and the teachers, select only those tuple where the instructor ID is clearly matches with the teacher's ID. Got my point? Meaning is that first you calculate the Cartesian product, that is instructor into teachers, and you will get this particular result. So from this particular result, where the instructor ID is mapped with the teacher's ID, means if the instructor ID and the teacher's ID is completely equal, select only those tuple as a result of the join operation. And this particular type of join is considered as the natural join operation. So these are the values. From this table, that is instructor into teachers, the Cartesian product, from this table we generated this table where the instructor ID is clearly matched with the teacher's ID, means you are quite assured that this particular instructor is taking care of this subject. So this particular operation is considered as the join operation. I hope that all of you understand my point. So first we discuss about the Cartesian product. That Cartesian product is a specific operation, or sometime it may consider as the cross product. Cross product is a kind of operation where each of the tuple from the first table is mapped with each of the tuple from the next table and generate a result. It's looking like some haphazard order, that there is no as such matching is there, and from this particular table we take the natural join operation, that where the instructor ID is matched with the teacher's ID, then we may say that this particular tuple may be joined. Okay, so that is the example. So next we focus on that thing again with some specific command, meaning is that if you check that here, the join operation allow us to combine the select operation and a Cartesian product operation into a single operation. So all of you please note down that point. These are the very important, that join operation allow us to combine the Cartesian product and the select operation. Means join operation hold a Cartesian product and a select operation, it's must. Good. Consider two relation. One is R, S. Here R is the relation and capital S is the relation, and small r and s considered as the instance. You may consider it's a relation or may instance of the relation. There is no effect. Okay. So here the thing is that the theoretical term is that R join S, means R should be joined with S depending on the selection predicate theta. Here the theta term is denoted as the selection predicate, means R joined with S depending on the selection predicate theta. It is equal to select from the Cartesian product of R into S, select the tuple from the Cartesian product of R into S depending on the selection predicate theta. So here in next table that thing is clearly mentioned. The right hand side part is elaborated here. Sigma is there. Theta is considered as instructor ID equal to teacher's ID, and R into S means instructor into teachers. And the left hand side, is clearly mentioned here in that side, that R is replaced by the instructor, S is replaced by the teachers, and selection predicate is instructor ID equal to teacher's ID. Means Cartesian instructor is joined with the teachers depending on selection predicate instructor ID equal to teacher's ID. So this particular line means the left hand side, and the right hand side meaning is same. In left hand side, that is the notional identification, or it may consider as the theoretical notation, and in right hand side it may consider as the logical notation. Okay, so that is the differences. That is a natural join operation. So now we are focusing on some of the example. So you may look out in this example. I hope that all of you understand that thing clearly. So in banking example, if you consider in a banking example, there are a number of relations may be there. Branch information is there. So branch is a relation with branch name, branch city, asset. Customer is a relation or table where customer name, customer street, customer only, that is the attributes. Okay. Account is a relation. In account number, branch name, balance, these are the attributes. So here total 6 relations are they exist in a bank. Now we find out, for example, if the tuple is like that, find all the loan information over $1200. How can you find? So for that purpose, find all the loan information means select from the table loan, where the amount is greater than 1200. So in your exam, question may become like that some relations are mentioned there, and from this relation we are asking about the query that find all the loan over 1200. So you have to easily find out the relation first, that if it is related to the loan, means we have to focus on this particular loan relation. So then where the term is find all, then you must have to use the select. So select from the loan table, depending on the selection predicate, that is amount over 1200. Good. Then again find the loan number. Here all term is not mentioned. Find the loan number only. So it is clearly understand that projection must be used. find the loan number for each loan, means find the loan number from the loan table. So that's why I use project the loan number from the loan table, but here some subquery part is there, from those loan where the amount is greater than 1200. So that is the simple meaning. First we select all the tuples from the loan where the amount is greater than 1200, and from this particular tuples or rows you just find out the loan number column. Okay, so these are the examples. So these are the next example, you may check that thing. Lots of examples we have created here. Lots of examples we have created here. Here we use the union operation and intersection operation. So better to avoid this particular example. First we clear about the intersection and union, then we will surely focus on the next particular. So here the things is there. Find the name of all customer who have a loan at the Perige branch. Okay, so how you can find that thing? That here the customer and loan, both the table are very important. So that's why the customer in the sense here it's considered as the borrower, means those who are taking the loan. So there is a relationship between the loan and the borrower. So that purpose we are here select from the Cartesian product of the borrower and the loan, where the borrower loan number must be equal to the loan number, obviously, because in borrower loan number and in loan table one loan number must be common. So select this tuple, then after that we again use the select operation, that from this table we again use the select operation that select only those tuple whose branch name is Perige only. We select only those tuple, and after that we found the customer name only, that is dependent on the project operation. So it's like that. That is considered as the example. You may consider that thing. Okay. So various examples are there. First we complete the next part, then again we are focusing on that thing. Okay. So next we move on to the next slide, that is the basically about the union operation and some other operation. So next is the union and the rename operation. Okay, next is the union and the rename operation. So first we focus on the two table. First we focus on the two table here. That 1 minute please. Yes. That in left hand side table and in right hand side table, 2-3 things are very common. In left hand side table name is, for example, the instructor table, and in right hand side table name is, for example, the section table, because some section information is there. So in instructor table total 4 columns is there, and in section table, that all of you those who are viewing, please take a snapshot of that, because if you are not taking a snapshot of this particular table structure, so from the next table it is very problematic to understand all that thing. Okay. So please take a snapshot of that. Okay. So in left hand side that is the instructor table, and in right hand side that is considered as the section table. So in both of the table, now we are focusing with the union operation. So in union operation meaning is that combining the two relation, and the notation is R union S. So before that, for the natural joining purposes we use R join S, and here we are use R union S. So that is the notation for the union. So now the condition is that R union S is valid only if R and S must have the same arity. Same arity in the sense, arity term meaning is the sense same number of attributes. Okay, R and S must have same number of attributes. Okay, so relationship R and relationship S both have same number of attributes. So now the thing is that whenever you are taking two relation or two instance, better to say two instance. Okay, so same number of attributes must be there. Okay. Next, the attribute domain must be compatible. Meaning is that in both of the instance or in both of the table, the attribute domains in the sense, if the first attribute and the second attribute, third and fourth attribute, in all the attribute the length should be same, and the domain of the attribute, means the data type of the attribute must be same. So from the right hand side table, so we are focusing on the right hand side table only. So from the right hand side table, if we say that one instance is R, another instance is S. So now if I say that thing, find all the course, not the whole tuple, find only the course information, find all the courses that are taught on the fall 2017 semester, or in spring 2018 semester, or in both. Meaning is that find out the courses that may be taught in fall semester of 2017, or in the spring semester of 2018, or in the, for example, or in both the semester, that is maybe in the fall semester, or that is maybe in the spring semester of 2018. So if I found, so from the right hand side table, if we check that thing, that for fall semester 2017, CS 101 is there, CS 347 is there, PHY 101 is there, these three courses are there. And from the spring 2018, CS 315 is there, FIN 201 is there, MA 199 is there, HIS 351 is there, CS 101, that is common in fall and spring, CS 319, then in CS 190, then in CS 319. Okay, so CS 319. Okay, so here if we check that thing, that CS 101, that is not that is common in both the semester, spring and fall of 2017 and 18. 315 is in spring 2018 only, and CS 347 is only fall 2017 only. So using this tuple information, that first find out all the courses that is on fall 2017, then we union all these courses with the courses that is on spring 2018, and the result is like that. So for this particular query, the result is like that. Okay, all the courses we have covered, means those who are fall in 2017 only, or in spring 2018 only, or in both. That is the union operation. I hope that all of you understand that. So next we proceed on the next part, that is the set intersection. So in set intersection, one thing is very important, that set intersection meaning is that it is simply considered as the intersection. Set intersection is simply meaning as the intersection. Meaning is that is very simple. All the conditions with the R union S, that is same, that both have same number of arity, and the domain of the attributes, that must be same, and thus difference is that here both condition is here only condition is not there, means the common value should be there, means those courses are available in fall 2017 that should be available in spring 2018. So you are finding the courses that is available in both in fall 2017 and in spring 2018. So if you find out from the table, right hand side table, only CS 101 courses is there, that is available in both the semester. That is the set intersection. Okay. So next is the set differences. Set differences are very important. Condition is same. Condition is completely same here, that the courses that must be available, in R and S, in both the relation, that is same number, same arity, same number of attributes, and the domain of the attributes should be same, means that should be compatible. Now the thing is that here the difference is from the union and the intersection is that find all the courses in fall 2007 semester, but not in spring 2008 semester. Okay, find all the courses that is available in fall 2017 semester, and that is not in the 2018 semester. So what is the meaning of that? Meaning of that, first you find out all the courses that is available in the fall semester of 2017, that three courses, 101, 347 and PHY 101. Good. Now find out the courses. So from these courses, from CS 101, CS 347 and PHY 101, find out only those courses those are not available in spring 2018. Meaning is that first you find all the courses from the first table, then you find out the common values with the next table and discard these values. I hope that you understand my point. First you check that thing, that find all the courses from fall 2017 semester, then find the same values from the spring 2018 semester. If it is match, discard, check only the differences, that is the set differences. So someone may be question that thing, sir, in fall 2017 semester, your point is very correct, that 347 CS 101 is available in both the side, discard it. CS 347 and PHA 101, that is not available in spring 2018, that is considered. But in like that, FIN 201, MU 199, HIS 351, these courses are available in spring 2018, but these courses are not available in fall 2017. Why you are not considering that thing? The clear answer is that here we are finding out the set differences from RS. Meaning is that we are finding all the courses from R and check the differences on the S only. That is not S difference R, that is R difference S. So whose particular value is in front, we are finding the similarities from the second table. Means check the similar value of R in the from the S, not from the S minus R. That thing should be clear. Okay. So next we are focus on the assignment operation. Assignment operation is very important. Meaning is that the assignment operation is denoted by the arrow sign. Meaning is that for example, if I say that from the instructor table, find the instructor those who are belongs from the physics. So here the assignment operation is denoted by arrow operator and works like assignment in programming. Meaning is that find all instructor in the physics and the music department. Meaning is that find all instructor. So to find all instructor from the physics department, we simply use select from the instructor where the department name equal to physics. So this particular query is mapped to the result, that the result is asking that from the physics department. It's just a notional changes, no actual changes are there, no actual changes in the query. The relational query is just assigned to the result part. The relational query is just assigned to the result part. Means if you solve this particular query, you will get all the instructor name that are belongs from the physics department. That is the use of the assignment operator, not like that. Means problem is in the right side and result in the left hand side. That is the meaning of that. That is the using of the assignment operator, not others. Okay. So next is the rename operation. Rename operation is a very important, meaning whenever you are using this relational algebra, one or two things is very important. For example, that in this relational algebra, whenever you are fetching the result or whenever you are getting the result expression, the result instance does not hold any kind of name. So for that purpose we use a rename operator, that is the row operator. Row operator is basically used for that in your SQL query. Sometimes you may use that rename option, that for example that set column name like that. Okay, it's like that. For example, whenever you are using, for example, if I say that thing, that give 1000 rupees increment in the annual salary of the employee. So in employees, in salary part, we rename the value that salary as. We use the operator as. Select the employee salary as salary plus 1000. So the salary column name is changed as salary plus 1000. So it's just normally like that. That you may change the expression name depending on the rename values. So here E stands for the expression, rho stands for the rename operation, and X stands for the rename name. Return the result of the expression E under the name X. So another form of the rename is E. The expression E is denoted either by the X denoted by the x, where x hold this particular attribute, that is a1 a2 dot a. That is the things. Okay. So next is the equivalent queries are there. Equivalent queries meaning is that some equivalency must be there, that there are more than 1, 2 or 3 way to express the relational algebra. Like your SQL. In SQL you may use select operation, you may use some different kind of operation to project the same result. So same here in RQL or relational query language, you may use some different queries. For example, if I say find the information about the courses, find the information about courses taught by the instructor. Find the information about courses taught by the instructor meaning is that find the information about the instructor, those who taught the course in the physics department with the salary greater than 90,000. So there are only first matter is that select the instructor tuple, where the instructor belongs for the department physics and whose salary is greater than 90,000. That is okay. Another way is that you may divide this AND operation in two parts. First you select all the instructor whose salary is greater than 90,000. Then after that you may find out that from this tuple whose department name is physics. Meaning is that instead of using a AND operation, you may use some nested kind of consideration. Meaning is that sometimes you may use the conditional operator that for and again some conditions. Okay, so here sometimes you may use for under for, means nested loop. So it's like that. Using of the AND operation, you may use some nested concepts there. But in the second case, the overhead is quite maximum because you are running the two select operation. Means you have to process two different queries. So overhead is quite maximum. But in that cases, the computational power is maybe required some more, but the overhead is quite less. But in both the cases, the result is the same. That is the ultimate goal. Okay. So next is the very important, that is the equivalence of the query. Once again, that there are more than one way to express the relational algebra. For example, for the same information, the query like that select the department name that equal to physics from the instructor joined with the teachers table where the instructor ID equal to teachers ID, and the same thing may be repeated like that. Select the department equal to physics, select the department name equal to physics from the instructor table, and it should be joined with the teachers table where the selection predicate is instructor ID equal to teachers ID. So in which method you are going to use, that is depend on your credibility. Okay. So after that we are focusing on the examples. Next, some of the examples are very common in both the sides as we already discussed. These are the examples. You may check these examples one by one. Okay. So find the name of all the customer who have a loan and account or both. So obviously who have a loan or account or both, then you must use the union. Means select the customer name from the forward table. It should be union with the depositor table. Means those who have an account or those who have a loan or maybe both. So next is the same. Find the customer name only from those who have a loan and must have an account at the bank. So you may use set intersection operation. Okay. So next is find the name of all the customer, those who have a loan in the Page branch. We already discussed this particular point. The next one is very important. Find the name of all the customer who have a loan at the Page branch but do not have an account at the branch of the bank. So this type of minimal examples are there. Okay. So if you have any query, you may ask the query. Rather, I will open the quiz link. You may check the quiz link. Okay. So I am open the quiz link now. So here find the name of all the customer who have a loan at the Perich branch, means we are going to find out the customer name only. So obviously project customer name only. So now that is who have a loan at Perich branch. So select the branch name Perich, and within that the relation is select the loan, means maybe you are a borrower and from the loan table. So borrower and from the loan table Cartesian product whose loan number is matching, select this tuple, then filter it by the Perich branch, then it is sent to project. Okay, so that is the query 1 and that is the query 2. So both are the meaning in the sense both of the result are the same. You may use in different scenarios. Okay. So again the next example, you may check that thing. Okay, so if you have any query or questions, you may ask. Rather, you will complete the quiz, then you may leave. Okay. Okay, so complete your quiz within time, and if you have any query or questions, you may send me so that I can answer. Okay, if no query is there, I am closing the session. You must complete your quiz within 2. After that, the link will be closed.